In UniFi Network Controller, if you go to Clients, then select your Wi-Fi device, go to Settings, you can see this interesting option, Log to Access Point. If you enable it, you have the option to select which AP to log to. You may wonder what's the magic behind it, how it works. So in this video, let's talk about it. There will be 4 parts in this video. First, let's use a UniFi Wi-Fi client device, a G4 doorbell. Let's look into the client itself and the AP settings, and then let's check the captured Wi-Fi frames to understand how it works. The second part is let's pick a non-UniFi Wi-Fi client. In my case, I'm going to use a Mac Mini. I will first look at a scenario that it really works when it comes to log to AP. Then let's check in what situation it does not work. The last part of this video is to answer many people's question. If you log the client device to an AP, what if the AP is down? Whether the device will fall back to another AP or it will lose the connection forever. Okay, there will be a lot of things to discuss. Let's get started. Let me first use a UniFi Wi-Fi device as example. UniFi Protect G4 doorbell. Let me first SSH into the doorbell. Okay, I'm in. I already discussed how the Wi-Fi client and access point selection works in UniFi Wi-Fi devices. So in this video, I will directly use the tool in the SSH session. But if you have a question about why I'm using it, how it works, you can check my previous video. So let me run WPA CLI tool. As you can see in the network controller, currently this G4 doorbell is not logged to any AP. So then by default, the device will connect to the one which has the best signal to noise value. It should connect to this one. Let me run scan command. So by the way, in the result, you can see all the 5 access points. They have the same frequency and they are all for 5G. To simplify this video, I already set all my 5 access points to use 5G only, and they have the same bandwidth and the same channel. And from the SNR value, the signal to noise ratio value, you can see the very first one, the strongest one, the MAC address, and with 2D76, which is exactly this one, right? That means if I do not change this log to AP setting in network controller, it is connected to this one. We already confirmed that. Now we are good to make the setting. Let's see how it works from the client perspective. Don't worry about the backend. We will look into the AP and the captured frames later. Let me switch on log to access point. Choose this particular AP as the log to AP. I believe this one is the U6LR. Apply the changes. Give it some time because it will do the provisioning to all the APs. Later you will see why. So here we only say we want to log to this AP, but in fact the network controller is doing the configuration changes to all the APs. Give it some time. Now let's run the scan command again. Okay, see the result? It first tried the 2D76, which is this AP, and it get message blacklisted, and then it tried the next strongest signal one, a C346, which is this one. It got the exact same error. It's blacklisted. The third try is the 8A3D, which is the one we wanted to log to, right? And this time it works. So from client perspective, we already validated, yes, this log to AP works. And now the client, the doorbell, is connected to the AP we set to. Everything works from the client perspective. Now let's answer the real interesting question, how it even works. To understand how it works, we need to first check the AP to understand why this particular AP refuses service to this client. Then let's check from the client perspective how the client even knows, okay, this AP doesn't work, and let me connect to the other AP instead, right? What's the magic there? On the screen, I show you two SSH sessions to the two APs. Now let me log on to the two access points. So the right side one is for the original AP. Now the client cannot connect to this one, right? So let's check a file under the folder TMP. The file name is system.cfg. There are a lot of information here, but we just want to search the MAC address for this particular Wi-Fi client, the G4 doorbell. Let me search 08:CB. Yes, there are a lot of hits, and let's see what they are about. So see here, it's under MAC ACL. It's the access control list for this particular AP, and the status is enabled. The type is log to AP. So the log to AP setting in the network controller is implemented in the access control list setting in system.cfg. This explains how this AP will refuse service to this client. See the policy? The policy is deny. It will deny service. Then you may ask why. See in the below part, you see another occurrence of this MAC address, right? Why there are multiple? Because this AP has multiple SSID. For the same SSID, it may support 2.4 gigahertz and 5 gigahertz. So that's why there are different devices for the same SSID. That's why you may find multiple occurrences of your client's MAC address. Just by checking this part, we already understand from AP perspective how it works, how this AP will refuse service to this client. So we checked this AP. Now let's do the exact same thing, but for this AP. Remember what's this AP? This AP is the one we set in network controller that we want this device to log to, right? So let's check the same file in the left side. The same way, search the MAC address for the client. Okay, pattern not found. It means this AP doesn't have this client in the deny ACL setting, which means this AP will not deny service to this client. So that's why this client is able to connect to this AP. That's where the difference is for these two AP. If you check the other APs, they will have the same situation as this particular one, because among the 5 APs, we only want the client to connect to this AP. So only in this AP's setting, you will not find this client's IP address in the deny list. Okay, I believe that's clear from the AP setting perspective. Now let's check from the client perspective. On the screen, I show you a Wireshark. It displayed the captured frames, which I used in the left side Mac machine to use the built-in sniffer, capture the Wi-Fi packets. And let's examine the packets to see how it works from client side. So because there are a lot of frames captured, I apply the filter in Wireshark. I only want to see the frames which I'm interested in. Let me briefly talk about the filter. So basically what the filter says is I only want to see the Wi-Fi management frame, and I only want to see the probe response or authentication or deauthentication or association or reassociation or disassociation or the four-way handshake packets. Now let's see the captured packets. So you can see a whole bunch of probe response. So basically the doorbell asks for all the APs to see which one to connect to. Then it decides to connect to see which one to the 76. See the diagram, the original one, right? So we do not want the doorbell to connect to this one, right? But anyway, the client, the doorbell doesn't know that. So the doorbell simply choose the strongest signal AP and try to connect to it. So naturally, first authentication, then the authentication process started. If we click on the association response, if we check the wireless frame, see here the status code unspecified failure. The AP simply reject service. The AP simply say, I don't want you to connect to me. There's no any particular reason. So unspecified failure. And then the client knows, okay, this AP doesn't work for whatever reason. Let me try next one, right? So see, it will continue receiving the probe response. Later, it decides to connect to another AP. See what's the AP's MAC address? C346. It's this AP. The client tried to connect to this one, but exact same result. Let's check the association response. See the status code, unspecified failure. So this AP also rejects service. Then the client have no choice, keep trying. And then the third try, see what's the AP's MAC address, 3D8A, exactly the one we lock the client to. We did the setting in the network controller, right? See what happened this time? Let me check the association response first. See the status code, successful. So finally, this AP accept the service, and then you can see the EAP OL messages. They are for the four-way handshake. That's how the client successfully connected to the log2 AP. Okay, so by checking the captured frames, I believe now you completely understand from both AP perspective and from the client perspective how the so-called log2 AP works. There's no magic. The only thing the system changed is the AP's ACL. Only for the log2 AP, it doesn't have the client in the denied service list. And for all other APs, this client will be included in the denied service ACL list. That's it. Now let's move on to the second part of the video. Let me use a non-UniFi device, a Mac machine, as the client. Let's see how it works. So in the network controller, you can see for this Mac Mini, I don't have the log2 access point enabled. In the lower part of the screen, you can see the session for this particular Mac. If I display the Wi-Fi details, you can see the BSS ID ends with 44CE. So see the diagram, which one is 44C? It's this one. So currently, without enabling the log2 AP, the Mac is connected to this AP. Now let me change the setting to force the Mac to connect to this particular AP. Now let me enable log2 AP. Then this particular AP is the one I wanted to log to. Apply changes. Give it some time to complete the provisionings. And from the Mac Mini side, let me disconnect Wi-Fi, then connect again. Okay, connected, and see what's the new BSS ID here. It's 8A3D. Exactly the one we wanted to connect to, right? So the expected result, the same result as in previous case, the UniFi device, right? Nothing special, and I won't waste your time to show you the captured packets because it's the same effect as the first case. Let's quickly finish the second part for the non-UniFi Wi-Fi client when it works. I did find some scenarios that it doesn't work. Let me show you. Let's start the third part of this video. Now let's discuss a situation that it doesn't work. So I'm going to use the exact same Mac, but this time let me change the log2 AP to the number 5. This AP is the one which is very far away from this Mac, so it has the weakest signal strength. So in the right side, in the network controller, let me keep enabling log2 AP, but choose another access point. Okay, save setting, give it some time. Then from the sniffer machine, let me start capturing frames. Now let me disable Wi-Fi and enable it again. See, it keep trying, but waited, simply doesn't connect. Now let me stop sniffing in the sniffer Mac. Then let's check what happened behind the screen. Now I'm using Wireshark to show you the captured packets. So it's very interesting. It's very busy. A lot of information here. So let's see what happened. See the first authentication part, association request, and then response. And let's see what's the response code. Yeah, unspecified failure is expected. See from which AP? 44CE. It's this particular one, right? Yeah, that makes sense because this one has the strongest signal, but it failed. No problem. Proceed. The next one, again, unspecified failure. From which AP? From C346, which is this one, right? So this is the second try. It failed again. Makes sense? Move on. The third try from AP8A3D. It failed due to the same reason. Which one is 8A3D? This one, right? So the third try failed again. Make sense? Move on. The next one, 44CE. Which one is 44CE? Interestingly, it's going back to the very first AP. It just go in a loop. See, the next one is C346 again, and the following one 883D. So again, it's going in a loop among these three APs. The Mac never bothered trying to connect to this two AP, and because we set the log2 AP to the number 5, because it never tried, so it's never successfully connected to what we see from the Mac is it never successfully connected to any AP, but in fact under the screen it's very busy. It's going in a loop trying these three again and again forever. So basically this log2 AP setting never works. But why, you may ask? Why the Mac never tried this two? Because I know the locations for the 5 AP, so I can already guess it must be due to the weak signal of this two AP. Then let me show you what I can see from a Android based Wi-Fi analyzer. See, this is the Wi-Fi analyzer screen. As you can see, it shows several access points information, right? In the right side, you can see the RSSI, the signal strength. So for this particular number 5 AP, 4B46, let's see which one is 4B46, this one, right? The signal strength is -87. It's super weak. That leads to a major difference between the UniFi Wi-Fi client and non-UniFi Wi-Fi client, because different operating systems have different roaming strategy. For Mac machine, for Mac OS, the default roaming strategy is if the signal is lower than -75, if other APs with stronger signals exist, it will try the other APs. It will not roam to the weak signal AP. That's the roaming strategy for Mac. For our first case, the UniFi doorbell, it used the WPA supplicant to connect to Wi-Fi, and for that Wi-Fi client, it has its own roaming strategy. I discussed in details in my previous video. For that Wi-Fi client, it will still try, but for the Mac, it will not, even though we set it to log to this AP, because it never bothered trying this AP, so the connection will never be successful. Okay, that's a very interesting scenario. Now let's move on to the very last part of this video. Let's discuss an apparent concern after you enable the log2 AP setting. What if the AP is down? Whether your client will automatically fail over to another AP or it will lose connection forever. As you can see in the network controller for this G4 doorbell, I force it to log to this particular AP, and currently it is connecting to this AP, right? In the lower part of the window, let me SSH into this AP. The reason I log on to this AP is if I don't set log2 AP to this one, by default my doorbell will connect to this AP. That's why I want to SSH into this AP. Okay, I'm in. Now let me run this command. Remember, in this temp system.config we have the deny ACL. That's how the log to AP works from AP perspective, right? Now I'm already in this particular AP. Let me check whether in this config file, whether we have the MAC address for this doorbell. Let me run it. Yes, now the doorbell cannot connect to this AP because in the configuration file, we set that device to deny list. Now let me go to the server room, unplug the cable to this AP. Let's see what will happen. Okay, now I'm back. I waited for 5 minutes. So now if I check the G4 doorbell, you can see now it's connected to another AP, not the original AP, right? But let's check the setting. It still says log to AP and still set to log to this AP, even though this AP is already done. Okay, you can argue this just reflects the settings. Maybe that's how Ubiquiti works, but let me check whether this doorbell is still in the deny ACL list for this particular AP, right? Let me run the same command. Okay, see, it's not there already. The network controller will detect this AP is done, and then it will notify all the other APs to change their ACL to make this client still be able to connect to available APs. So that's why now doorbell is connected to this AP. So it seems it works even though I have to wait for 5 minutes. In my previous test before I take this video, it's effective right away. So basically it's not very consistent depending on when the UniFi controller detect the change, when it will notify all the other APs. Okay, but at least it works. Just to make the testing complete, let me go back and re-plug in the cable for this AP. Let's see what will happen. Okay, I'm back. You can see the AP is getting ready, and if at this time I display the ACL, you can see it's not refreshed yet, so the doorbell is still connecting to this AP, right? Give it some time. Now the AP is ready. Let me give it 5 more minutes. Let's see whether the ACL will be automatically refreshed, whether the doorbell will automatically roam to this AP, which it is supposed to log to. Okay, I have waited for 5 minutes, but after refreshing the UniFi controller, you can see it is still connected to the AP, which it fall back to. So it's not the AP which is supposed to log to, right? And in the SSH session, the ACL is already reflected. So which means either I give it time, the doorbell will automatically roam to this AP, or I can force the roaming in the SSH session, right? Okay, I don't want to wait because I don't know when the doorbell will try to rescan and try the roaming. So let me force it. I already SSH into the doorbell. Let me run the command WPA _ CLI, then run command scan. Okay, so you can see 2 blacklisted AP and it's connected to 8A 3D, which is the one we wanted to use, which is the one we log it to, right? And then from the UniFi network controller, let me refresh the interface. Now you can see the network controller correctly refreshed. The doorbell is showing connected to the AP, which we wanted to connect to. Okay, so now after the back and forth testing, now we are sure, even if the AP is done, the AP which you set log to is done. It's not the end of the world. The client will automatically connect to the other AP. The network controller will automatically take care of the changes. Okay, thanks for watching.